So based on shape, there are five types of bones found in body: flat bones, long bones, short bones, irregular bones, and sesamoid bones. Now, these bones, regardless of their shape, all have the both bone tissues in their structure. Basically, the outer layer of bones is made of compact bone. In another word, bones are compact on the outside but spongy on the inside. The first type we're going to talk about is flat bones. Some of the bones that are actually flat are the bones of the skull, sternum, and hips. Now, if you cut a piece of flat bone to see what's inside, you'll see a structure like this. This structure, which is flat bone, is made of three layers. Let's call them L1, which means layer 1, L2, which means layer 2, and L3, which means layer 3. If you look closely, you'll realize that L1 and L3 are both compact bones. The layer between the two compact bone layers, which is L2, is a spongy. This layer is called diploid. Now you know that spongy bone can have marrow. This is one of the places you may find marrow. So diploid can have marrow inside its holes. Actually, this is a major place you can find red marrow because flat bones are full of red marrow. Now let's talk about long bones. Long bones are the ones that make up your limbs. These bones make most of the appendicular skeleton. There's also another couple of bones which are classified as long bones but are a little bit different. They are the clavicles. Clavicles are considered as long bones, well, because they are long in their shape. But if you check the inside, you'll see that also looks a little bit like flat bones too. Plus, clavicles are the only long bones that are horizontal, unlike the other long bones which are vertical. Anyway, an ordinary long bone, like the arms bone, would look like this. Now, a regular long bone is made of three parts. The two big rounded parts at the both ends, which we call metaphysis, and a long part in the middle, which we call shaft, or you can call it by its fancy name, diaphysis. So the three parts are two metaphysical parts at the ends and a shaft in the middle. Let's check what's inside the long bone. It's mostly made of spongy bone on the inside. But look at the inside of the shaft. There's an empty space inside the shaft. This space is called the medullary cavity. This medullary cavity is filled with a tissue called yellow marrow. Yellow marrow is made of fat cells and it's actually some kind of a fat tissue. So unlike red marrow, the yellow marrow can't make blood cells. However, yellow marrow can turn into red marrow in some specific conditions. For example, in case of blood loss, and by that I mean very bad kind of blood loss, the body needs to make a lot of blood to replace the lost blood in order to survive. Now, the red marrow alone can't make that much blood. So, yellow marrow turns into red marrow to help the body replace the blood faster. Now, this is just some kind of a rare situation and may never happen. So, the marrow inside of the medullary cavity usually stays yellow. So, there is marrow inside long bones. But the yellow marrow inside medullary cavity is not the only one they have. There's also some red marrow inside the spongy bone of the metaphysial parts. So in conclusion, there's red marrow inside metaphysis, there's yellow marrow inside the medullary cavity of the shaft, and this yellow marrow can turn into red marrow in some special conditions. And also, clavicles don't have medullary cavity or metaphysis, which is another difference between clavicles and other long bones. So, clavicles keep the marrow inside along their length. Short bones probably have the simplest structure found in the whole body. These bones are found in wrist and feet. Now, if you zoom in a hand, you will see the short bones that make the wrist. These bones are called carpals. So carpals are the short bones of the wrist. As short bones, they are somewhat cube-shaped, which means that they are just as wide as their length. Just like any other bone, these bones are also compact on the outside and spongy on the inside. And again, just like most of the bones, it has marrow inside. Irregular bones, mostly found in vertebral column. Vertebrae are some irregular bones as well as sacrum and coccyx are. Now, as the name suggests, these bones are irregular and don't have a specific shape. You may see a vertebrae and think all the irregular bones look like this because the other vertebrae also look like this. But then you'll see the sacrum and coccyx, which are not even remotely similar to vertebrae. So these bones each have an unexpected shape. Again, just like any other bone, these bones are made of compact bone, but on the inside they have spongy bone. And these bones, again, just like most of the other bones, sometimes have marrow inside, but just a little bit of marrow. In the end, I'd like to talk about sesamoid bones. Now, before I start talking about these bones, I should warn you, some people don't actually believe in sesamoid bones. They classify these bones as short bones, which is not wrong, because the bones actually are short and look just like short bones. However, these bones have a whole other function. That's why they can be classified as a whole other classification. Now, a major sesamoid bone in body is patella. Patella is present on the knee joints. Some people even call it kneecap. So if I zoom in, it would look like this. Let's see how sesamoid bones actually work and why we need them. This is the knee joint. If you want to move your knee, you'll need a muscle to pull the bone. Now, muscles don't actually pull bones directly. Muscle pulls a string, and that string pulls the bone. That string is called tendon. Now, there's a lot of movements in joints like knee. As a result of these movements, a lot of friction is made. This friction is bad for the tendon and might actually damage it. Plus, sometimes some outer forces might damage the knee. For example, you fall down on your knee. That amount of force can be so destructive and may even cut the tendon. Therefore, we got patella, which protects the tendon. This is basically how any sesamoid bone works. They protect tendons. They act like a helmet for tendons to reduce the damage and also to lower the friction taken by tendon. Per usual, these bones are made of compact bone on the outside and spongy bone on the inside, and again, they can contain some small amount of marrow. One important thing that I want to mention once again is that in some references, sesamoid bones don't have an exclusive classification. In these references, these bones are considered as short bones. This type of classification is totally okay. The only thing is, in this classification, the function of these bones are not considered. Here for a summary, we first talked about flat bones, which will look like this. The spongy layer which is between the two compact layers is called diploe. Flat bones are a major source of red marrow,
and they keep the marrow inside the diploid. The next bone type we talked about is long bones, which looks like this. The two rounded ends are each called a metaphysis, and there's a shaft in the middle, which is also called diaphysis. Inside the shaft, there is an empty space which is called medullary cavity and has yellow marrow inside. Also, there's some red marrow inside metaphysis. After that, there's short bones, which are just too simple to be explained. They're just cube shaped, just as you can see in the picture. Then we got irregular bones, which don't have a specific shape, and each one of them are unique in their shape. And finally, there's sesamoid bones, which protect the tendons. And also, in some references, these bones are considered as short bones.